Welcome, everyone. Today we have the pleasure of welcoming experts from Satellite Applications Catapult, Emma Haskett, Dr. Ling Su, and Michael Kurtz-Strauss. Could you please introduce yourselves quickly for the audience with the talk? Thank you.
Sure. My name is Emma Haskett. I'm Business Strategy Lead for the Satellite Applications Catapult. My role involves working on commercial and strategic outcomes for both academia and businesses. I work a lot with startups where I help them to distill the value of the IP that they're creating and to generate commercial and economic value from it.
Good morning. My name is Mike Kurtz-Strauss. I'm Head of Manufacturing for Space for the Satellite Applications Catapult. What that basically means is I lead on the upstream technologies which span from spaceports, launch vehicles of all variants, in orbit servicing manufacture, our early developments around lunar and other associate manufacturing capabilities. I work with all companies from the small to the large, both in the UK and internationally.
Hi, my name is Ling. I'm the Knowledge Exchange Manager at the Satellite Applications Catapult. My role is mainly working with academics to help pursue their academic research to help space company to scale up and help the adjacent sectors grow.
Thank you very much for the introductions.
So we were hoping that Mike would kick us off with a general introduction to all of the wonderful things that we're doing in space right now. And then I'm going to follow up with some of the specific programs that we support around commercialization for academics. And then Ling will talk us through all the things that we're doing with academic engagement.
Emma, can you do a screen check for me? Is that up? Great. Emma, would you do me a favour and just tell me when to shut up, because otherwise I'm going to go through this fast, but there are about 30 slides here. So
okay.
Please give me a time check when you need me to stop, because you can stop me broadly at any point because each part is quite distinct.
Okay, great.
Cool. Great. Okay, so as I said, I'm Mike Kurtz-Strauss. I'm Head of Manufacturing for Space. I talk reasonably fast and I use a bunch of acronyms. I'm afraid that's just a consequence of being in this sector. My contact details are at the end of this slide deck. If we don't get there because I start eating into Emma's or Ling's time, please do reach out to the organisers and get my email details. I'm always very happy to talk. Generally, I believe on the premise that you can sleep when you're dead. So there were over 25 hours in the working day. So let's have a chat if you want to talk. So quickly, as a brief background to the Catapult, and these are our commercial slides, so I'll get these out of the way as fast as I can. Who are we? Well, we're an innovation and technology company that delivers solutions to transform the way the world uses space and satellite technology. We're an independent company, not for profit, limited by guarantee, and we're one of 9 catapults. What do we do? Lots of things. Basically, our market reach covers a whole variety of areas. You can see those in the 7 blocks to the bottom of the screen, and our sector technology is in the top, goes across the top. My area, in terms of manufacturing, impacts almost every single one of these areas. If you want to put something into space, if you want to build something, if you want to get data from space, you're ultimately going to have to do some form of manufacturing. So manufacturing fundamentally is everywhere. So manufacturing space, break it down a little bit further. What do? I get involved in satellite manufacturing, scale up from both small sats to much larger satellites to constellations, launch services, so all flavors of launch vehicles, from rockets to space planes to rocket balloons, which I hate with a passion, even catapults, not in the capacity we are a catapult, but catapults which can fling things into space. Super bad idea in my view. And also we touch on in-orbit servicing, manufacturing and repair. And finally, in the lower right-hand side, operation and mission control. So super exciting start to the year. Virgin managed to throw something into space without it exploding. That's a big bonus because, as many of you probably know, when you launch stuff, usually it explodes. The fact that they managed to launch it a second time and it didn't explode this time was great news for Virgin. What does this mean? Well, actually, it's an interesting new approach to space launch. In the past, if you wanted to put something into space, you basically took the equivalent of a missile, you put something on the top which didn't explode ideally, you fired it, and if you were lucky, it went into space. And that's pretty much what the space industry has been doing more or less for the last 50 years. Virgin have taken the approach of, let's take basically a commercial aircraft, stick a rocket under its wing. You can see that under the starboard wing closest to the base of the screen. Take it up to about 30,000 feet, release it with the payload, and then we can put something into space. Different approach, a lot of infrastructure, but not quite the same level of infrastructure you need for a conventional rocket launch. So, interesting place things are going. Spaceports, lots of hype in the news. By 2150, are we going to have something which is a little bit akin to the USS Enterprise docking in an orbital spaceport? You know what? I thought this time last year I would have laughed at anyone who put this slide up and said absolutely no. But actually, judging where technology is going and our ability to build large structures and make significant progress, I think it's actually reasonably realistic to say within the next 100 years, possibly 150 years, we're going to see orbital spaceports, big things which can build big spacecraft, which will have the ability to go not just to the inner planets, but potentially beyond. Exciting stuff, but what's the reality? Well, Spaceport America, Spaceport One, designed by Foster & Partners, built for Virgin, designed to look like this. Super conceptual, looks really attractive. Would you believe it actually pretty much does look like this? So that spaceport, which is designed to look like, I believe, a winking eye. Why you'd need a winking eye to see from space, I don't know, but that I'm sure is hubris for Virgin. This is their spaceport, and it's operational today. The UK has similar aspirations. We have Sutherland Spaceport, which is one of 6 or 7 spaceports in Scotland, near Dunray, tip of Scotland. Looks attractive. This is Orbex's vision of what it's going to look like. However, our ambitions are not quite as perhaps moving at the same pace as the US. So today, Sutherland is a lovely place to, if you want to go bog snorkeling, but beyond that, no rockets there. Probably things are going to change. Why? Because we've got lots of spaceports. Right down in the tip of the southwest, Cornwall Spaceport, lots of news about them. Virgin aspiring to operate out of there. I'd throw the caveat in there. Virgin may well operate out of there. However, Virgin, on the basis of being able to do air launch, can operate from anywhere. So will they operate out of Cornwall? Will they operate out of Heathrow? Probably not Heathrow, but they could operate at an airport near you. And there's a variety of other horizontal spaceports, Prestwick, Campbelltown, Llanbedr in Wales, and a few others. And then in the north, we've got around Scotland, unsurprisingly, the vertical launch sites. So Benbecula, Sutherland, and Shetland, all proposing to be spaceports. Will they be spaceports? I speculate not. I suspect the UK will have 1 or 2 rather than 7. But still, it's a bold ambition. So why is there this mass desire for effectively spaceports and rockets and all sorts of craziness? Well, it comes down to basically new services and products, something we as a Catapult have a big emphasis on. Space now being able to be a viable market environment, a commercial environment for new organizations, is seeing a huge surge in new products, new innovations, new platforms, new capabilities. The more products you have to put into space, the more capability you need to put those things into space, and that in turn creates adjacent services, benefits, markets, etc. So it's a fast-moving environment. And we're also seeing a growth of what we term as in-orbit service and manufacturing, IOSM. IOSM is basically about doing things in space which we don't do on Earth. So whether that's servicing and refueling a spacecraft, whether that's manufacturing a part in space for use in space or potentially return to the Earth, whether that's repair of a spacecraft or whether it's something else. IOSM is a really, really major market. The image on this screen is the Northrop Grumman mission extension vehicle, successful mission MEV-1, which is about 2 years old now, where basically a defunct telecommunications satellite was orbit boosted to a higher orbit by a second spacecraft coming up specifically to dock to it. And bearing in mind that the original spacecraft wasn't designed to be docked to, they had to develop a mechanism to effectively dock to that spacecraft and then orbit raise it, thus extending its life and thus bringing back into life a satellite which originally cost $30 to $40 million and now has a potentially viable life. The other factor, and many of you will probably be interested in this, and this is very much Emma's world, not mine, is about investment into space. And we've seen this massive surge in the last couple of years, led partially by organisations in the UK like the Seraphim Space Fund, where we're seeing direct investment into companies who are doing what would have been perceived in the past as frankly uninvestable products. So whether it's Isotropic, who have actually raised another $40 million in the last week based around antennas, whether it's Spire getting close to 17 million euros from the Scottish enterprise building small sats, or whether it's ISAR Aerospace, a German North Sea launch company, getting over 15 million euros. We're seeing money coming out of different parts of the financial sector flowing into companies which in the past would have been considered unfundable. And that's why investment is getting bolder. At the same time, we're seeing a transition from what might have been perceived as science fiction or something you would see on Netflix into something which is today fundamentally viable. And this includes things like solar orbital power, building a solar power station which can beam energy to the Earth, not as a death ray. We're not intending to cook things other than perhaps some plants, but beaming that energy to Earth, which can directly be converted back into electricity and then therefore thereby power our cities, our lives, our society without the equivalent net zero consequence. But I thought you'd like to see some maths. Everybody likes to see maths, particularly early in the morning. And this is early for me because it's 11 o'clock and it's definitely early. So that's all the maths I'm going to show you. Rockets, basically everyone thinks are complicated. They're not. They're really dead simple. All we have to do is basically fire something high enough, fast enough, and further away from the Earth as possible. And basically, more or less, it will stay in orbit. The problem with this is that now everyone thinks building rockets is super easy. But the problem is rocket engines are really complex to build. Oh no, somebody invented something called 3D printing, which is a super annoying process, which personally I'm an evangelist for, just not for rocket engines. 3D printing allows you to take really complex objects and allows people to design super complex things and then make them in a really easy and accessible way. This is good in some ways, as long as you know what you're designing and why you're designing it. The so what of it is, if you don't understand it, then you end up with bad things happening. So it doesn't matter really whether you're SpaceX in the case of building Falcon 9, which yes, some of them work, but yes, a lot of them still don't work, or you're playing with model rockets with your university society, which if you're super unlucky, they might chase you, or if you're the Japanese of bringing all your investors to an H5 rocket launch, only to see your rocket not even take off, it actually fell down and exploded. These are complicated technologies. Do not simplify rockets. 3D printing doesn't make your rocket building easier. But apparently, people don't listen to me. So 10 years ago, we had about 10 or 11 companies building rockets around the world. Today, we have, well, actually, it's not even 289 because as of this morning, I have a new company who wants to talk to me about the market opportunity for something brand new called a small satellite launcher. Great. So we have 290 companies as of the 11th of February, 2021. Are they all going to succeed? Absolutely not. I hope most of them will fail. Why? Because most of them are bad ideas. However, the people involved, the engineers involved, the technologists, the entrepreneurs, they'll go off and do other things. So if anyone here is listening and is involved in a rocket company, I really do hope your company succeeds, but it probably won't. But when it does fail, go off and do something else exciting because it won't be an experience lost. Back in the UK, we've got a bunch of people building rockets. So this is Skyra, who are a Ukrainian Scottish company. They're proposing to build a two-stage rocket weighing about 20 tons on takeoff. You can see a pseudo mock-up of it in the left image and their 3D printed engine on the right image. Suffice to say, the engine roughly does work. This is Orbex. This is a Danish UK rocket. Not much, you don't hear much about basically Orbex, but realistically, Orbex are looking to build again about a 20-ton rocket, two-stage, heavily focused on carbon fibers and a whole chunk of 3D printing, but they're planning to operate probably in the next 18 months, and I suspect they will be successful. Back down to ground, spin out from the University of Cambridge, Proto-Launch, exciting bunch. They're currently in our Westcott Incubation Centre at the Westcott Venture Park. They're building a novel engine which basically doesn't use turbopumps. Turbopumps are spinny things which, when they go wrong badly. Proto-Launch have decided to use a pressurization system which mitigates the need for those turbopumps. Again, it's 3D printed. In this case, it's probably the right technology, but you can see where the technology trends tend to go. So going into some of those other things, why, effectively, why are people doing things? Why do we need to launch rockets? Why do we need to launch satellites? Well, actually, maybe we don't. because programs like Copernicus, which are run by the European Space Agency, which is a service of up to 6 satellites providing freely available data, allow you to do a whole bunch of things without necessarily needing to invest in your own spacecraft. You can just use that data from someone else, from ESA in this case. So organizations from around the world have been using Copernicus-based data, which is free, to do everything from tracking whales in the North Atlantic to tracking drifting vessels linked to maritime safety and security. So in some cases, you don't need to launch anything. You don't need a satellite. You can just utilize the data which is already there, freely available from significant and high fidelity programs launched by other people. Of course, that's not always the case. Sometimes you need to do it yourself. And particularly if you want to do communications. So everyone's probably familiar with Starlink, 955 Starlink satellites, 895 currently in orbit, 60 or so are orbital spares, a constellation that, depending on which day you catch Musk and depending on what he's been smoking, he'll tell you it's anywhere between 1,000 satellites to 30,000. The key thing about constellations is, particularly in the case of Starlink, which provide internet broadband globally, is you can't offer the service until the constellation is complete. So Starlink is almost operational, but not quite. So there's an enormous amount of risk about putting things into space in constellation size, because if you don't complete your constellation, you ultimately cannot generate a revenue. On the flip side, we've got OneWeb, invested heavily by the UK last year to the tune of close to 500 million sterling. And OneWeb, its various generations, Generation 1, which has 75 spacecraft currently in orbit, Generation 1.5 and Generation 2 are intending to provide additional services beyond just communications. So the expectation is the incremental delivery of what we call position, navigation and timing services. So for phase 1, resilient timing for critical national infrastructure. So that's the critical infrastructure that makes everything from your airports function to your traffic lights work to your mobile phone function. Commercial positioning services necessary for autonomous vehicles. They need a much higher, greater fidelity in terms of positioning, right down to enhanced position navigation services, which is about giving government very specific capabilities for communication and very accurate positioning. So OneWeb is more than just purely communications as it was originally specified. It's now about looking about PNT or GPS in some capacity. But there are alternatives to mega constellations, and these can be swarm-based systems. So there's quite a lot of interest in terms of basically looking at spacecraft which manufacture themselves on orbit, effectively can replenish themselves, can deploy themselves fast. They leverage advanced manufacturing, digital systems, RF technologies to really rapidly deploy small satellites, which might have a lifetime of only a few months, but you can put up one big satellite which rapidly duplicates itself and very rapidly create yourself a mega constellation without the normal cost implication you would do so from a Starlink, Samsung, OneWeb, Black Star constellation equivalent. I touched earlier on IOSM, in-orbit service and manufacturing. What is it about? Well, it's about all of these things. I've touched on some of these so far, like transportation, but inspection, maintenance, assembly, refueling, and even debris removal. Just being the caveat there that debris removal is always interesting, but unless someone's paying you to do it, it's not necessarily a good business model. So it's going to be really interesting to see how companies like Astroscale propose to actually make money by removing debris from space. My view is they probably will only be focusing on actually moving spacecraft which are defunct or need repair, rather than actually being the clean sweepers they aspire to be. But who knows? Almost today, but not quite today, is what we call the trans-cis lunar economy. And this is basically the economy in space moving from low Earth orbit to low lunar orbit and everything in between. So we've already got the ISS up there. There's activities already exploring solar power stations, manufacturing in orbit, communication satellites, the Artemis program planning to build the gateway, which is under construction, which is at the L1 point. And then it's starting to look at exciting things about lunar prospecting. Why do we go to the moon? Ultimately, there's no reason to go to the moon whatsoever unless we want to practice going to Mars, with the one slight caveat of the one thing the moon does have is that it has ice. Ice we can convert into oxygen, we can convert into water, and we can convert into rocket fuel, which are 3 of the key things we need if we're going to explore the inner solar system and potentially beyond. And also manufacture things in orbit. So the zero gravity environment with the benefit of being clean, low vacuum, and effectively radiation harder in some respects, but the microgravity aspect specifically allows to manufacture things in space. So everything from ultra high quality optics, thin film products, pharmaceutics, which can be far more potent at treating various types of cancer, to microencapsulation and high fidelity semiconductors. There are organizations out there already beginning to look at it. And in one case, ZBLAN, which is a fiber optic cable which has superior properties to those which you would find on Earth, there are already systems owned by Redwire and others who last year bought Made in Space, manufacturing ZBLAN on the space station. Typically, a ZBLAN fiber per meter has a cost benefit of at least 4 times to 10 times better than that of fiber made on Earth. Why? Because ZBLAN space fiber is clearer, and the clearer the fiber is, the more data you can send through it, the lower the latency, the higher the bandwidth. And thus, in an age which is driven by digital capability and very much everything from literally the way we're presenting today to the phones that you use and over to medical fiber for medical lasers, high bandwidth, low latency fiber is super attractive. So there are companies looking to build this. In the background, other things, people planning to go to the moon, SpaceBit, super exciting little company based in the UK and a bunch of other places, building a tiny little robot the size of about 4 fat hamsters. Take a look at them. They're an interesting bunch. They're recruiting, which might be of interest to some of you. Wrapping up fast, Orbital power plant. We've talked about this a little bit so far. Basically, think of something which is about 3 kilometers in diameter, converts solar energy into electricity via photovoltaic cells, converts that via an energy converter into microwaves, beams that to Earth into a microwave receiver about 5 kilometers in diameter. Why microwaves? Because they're low power and they don't cook aeroplanes and birds, which is good unless you're KFC. Great impact for effectively trying to meet the UK net zero energy target. This is wrapped up in what we call the International Space Energy Initiative, which the UK is leading. Aspirations to build a solar power station in the next 20 years. That's me. Thank you very much.
Thanks, Mike. That was awesome. If it's okay, we're just going to hang on to the end for questions across the board, and I'll just jump into my slides, although I'm slightly concerned that there might be a bit of death by PowerPoint going on, but hopefully.
Oh, that sounds perfect. Please go ahead.
So Mike has sort of talked you through all of the weird and wonderful things that are happening in the industry across both the upstream and the downstream, and there are lots of opportunities within the sector. And a key role of what the Catapult does is bringing that academic IP and pulling it through and commercializing it into the market space. So I wanted to talk to you a little bit today about the work that we do around academic commercialization support. So the support that we currently offer falls into 3 areas. What we call academic sprints, which are short burst support sessions that leverage our technical, business strategy and user-centered design expertise. Project support, so we do quite a lot of consortium building support to leverage grant funding opportunities that bring together academia and industry. And then spin out support for academics who decide they want to go it on their own, set up their own business. There are a range of incubation and acceleration support activities that we provide. So an academic sprint, what is it? Essentially, it is a one-to-one support session with an academic or a group of academics who are at inflection points. They're looking to translate their academic IP into commercial value. And there's a number of types of sessions that we offer, which are outlined below, but normally sessions are an overlap of a number of these things. So we look at market, what are the commercial opportunities? How big is the market? Is it growing? Who else is out there competing in the market? We look at users, you've got an idea for a product or service, which is great, but actually have you validated that with users and found out if it's valuable to them? We help to define services and service concepts and blueprints, define commercialization pathways. So, okay, we have an idea here. How do we get from this concept stage and a little bit of research that I might have done in the academic base to commercialization, and what are the vehicles I can use to get there? And then finally, communication support, which is always really valuable in this sort of tech and science heavy industry that we work in, where we get people who've got these wonderful ideas and capabilities, but need a way to synthesize the value of what they're doing to non-specialists. So the sessions themselves involve, depending on what the session is, a market session would involve doing some preliminary market research on behalf of the academics, really sort of exploring what the problem and space looks like and defining and really refining the value proposition and looking at those opportunity areas. So segmenting the market. This is the entire Earth observation market, for example. This is the piece that I'd like to do around sustainable finance. This is how big this market is, and etc. user engagement, we tend to do some co-development workshops where we'll bring end users or customers into the session themselves. So the academic gets a real understanding of what it is that's valuable from a customer's perspective in a service and how they'd like that to be packaged. Service design are about mapping out exactly what those steps are in terms of getting from your starting point to your product or service in the hands of the customer. And commercialization is really about understanding the interplay between the technology, the commercial, and the financial readiness of the business. So we need to put a plan in place in order to get to commercialization. We need to access finance in order to develop the technology. But at the same time, we also need to be bringing along the commercial readiness level of the company and being able to help companies map that out, and academics indeed in this case. And then finally, communication is about, depending on where, and this can be utilized throughout the innovation cycle, how can we synthesize the value of what we're doing to various stakeholders? So if you do decide to spin out your idea, your first stakeholders tend to be investors. You know, how do you convince them the value of what you're doing? And then that stakeholder group extends and extends to the point where you get to the customer base and really engaging the customer and making them aware of what it is you have to offer. Academic projects, we do a lot, as I say, of collaborations with industry and academics. Some examples here with Oxford, we've done a project around smart optics. We're working with Swansea University at the moment doing a flat panel antenna solution for mass market automotive, which uses hybrid SATCOMs and terrestrial communication. We're also working with the University of Exeter and particularly the Camborne School of Mines around a project called Satellite for Batteries, where we use Earth observation to prospect areas for lithium and other rare earth minerals. Columbia IPP and ESOS, again, are Earth observation-based collaboration projects that we've done. Finally, if you are moving beyond the academic space and you're looking to commercialize further and set up your own business and start out, we've worked with lots of spin-outs from various universities across the country, and we provide that support in a number of different mechanisms. So we have our own incubation centre, which is the Westcott Business Incubation Centre, and Mike does a lot of work actually with Westcott and the incubatees that come through there. The focus is around 5G, propulsion and drones. We also work very closely with ESA and their Business Incubation Centre based in the UK in the Harwell campus, and Dareford. I think there's a centre in Scotland as well. And then we provide support every year, a couple of times a year, to the Seraphim Space Camp. So it's a really good accelerator program for those companies that are really looking to access VC funding. In terms of how you fund the academic activity, there's a number of opportunities there. Traditional grant funding from a number of sources to do collaborative R&D projects. Research Council funding, fellowship funding has been used, and also Sprint funding. So the Sprint network is, I think, a network of 5 different universities that provide academics with funding to work with businesses to sort of work on challenges that they have together. And we do some of our Sprint activity through the Sprint funding program. That's me.
Okay, I'm just trying to load up my slides. Can you guys see my slide?
Yeah.
Perfect. So just my computer doesn't like Teams very well, so take a time to load it up. Okay, so probably just a quick step back why Catapult and the Catapult network was set up. So UK has been well known for its world-leading blue sky research, the discovery research. However, in comparison, we are doing less well in terms of innovation as opposed to our international counterparts. So the UK government set up the Catapults and the Catapult network about 7 years ago, and each of the Catapult have a sector focus. And as you can tell, the Satellite Applications Catapult is focusing on space, satellites, application, etc. To that end, The Catapult and this UK Space Agency in the past 6 years have been working closely together to build a space ecosystem across the UK. We do have international collaboration as well, as mentioned by Emma at the end of some of her slides. But across the UK, we have been working together with academics, industry, local enterprise partnership, as well as devolved administrations to build the ecosystem and also try to translate space technology into adjacent sectors, for example, healthcare, agriculture, so that we can help the UK to grow economically. To that end, academic engagement is really important. And here I just highlight why we're doing academic engagement using some of these blocks here. As you can see, academic engagement leading to knowledge exchange so that we can help to fulfill our mission. But ultimately, we are really trying to build this whole ecosystem. And in terms of how we work with academics, I just give some kind of mechanisms by different categories. But what I want to highlight is we are just a very important addition to the ecosystem in terms of innovation, and we are not competing with industry. We're really try to help to energize the market, to enable the technology, and try to scale up SMEs. And in terms of how we work with academics, I kind of grouped them into 5 different groups. The most common way we work together with academics is through collaborative research and development. And quite often we work on projects together with both academic and industry partners. The second way we work together with academics are really collaborative trainings and build the skill pipelines, quite often with industry as well, so that we can build the right career pipeline to suit the growth of the industry. The third is very heavily touched on by Emma, is really about commercialization. And we quite often work with tech transfer offices to help pulling through academic research. And in this arena, for example, I understand some of the audience are from Oxford and Warwick University. So we quite often work with Oxford Innovation and Warwick Enterprise to carry out those kind of activities. The fourth one is about infrastructure. So there are so many different complementary infrastructures across the UK. This sometimes can be data infrastructure, sometimes can be wet lab facilities. So we try to maximize the opportunities by working with the complementary infrastructures to maximize our offers. The last thing is how we work together with other Catapult network and share good practices and roll out the success models. I might touch on a little bit on that in one of my later slides. And here I also show very quickly how we measure success. So what we do is always subject to evaluation so that we know we are also progressing against our baseline and achieving something. Here are some examples of our KE activities with an academic partner or academic partners. So I quickly touch on here. This is a strategic outlook developed by our Chief Technology Officer. And as you can tell, it's plotted against a timetable, and there are 4 concepts ranging from positioning to infrastructure monitoring to OneWeb enabled communications, all the way to space solar energy. And the way for the young bright minds to get involved throughout some workshops is currently being organized by Knowledge Transfer Network. And we are going to call for contributions through our website so that you can come and join us and help us to build these ideas and deliver some of the development and implementation plans. And by developing this, we're also working very closely together with the Space Academic Network. So some of you might be member of those network. The other thing we are doing is called Researcher in Residence. So we have a number of researchers in residence. They are normal academics based in university, but this type of funding provided by Research Council help to buy out their time so that we can help accelerate the adoption of their academic research. And we also work together with other catapults. So for example, the Cross Catapult Net Zero initiative is one of our very important initiative at the moment to help combat the climate change, and also linked to the solar space solar energy, which Mike touched on earlier. We also run a number of emerging technology webinars together with academic partners. So those webinars help to raise awareness of all these emerging space technologies and what it might be used and translated in industry and various applications. And one last thing I want to touch on this very busy slide is something called the Space Enterprise Lab. So in light of COVID, virtual working is become more and more important. So we are launching very quickly, shortly, virtual networking space to help engaging with academics, industry, and also build a virtual community to facilitate collaborations between those different communities. In light of the audience here, I just want to give you some example how we actually work with different universities. So these slides give you a very quick overview how we work with Warwick universities. So within the Catapult, we have different teams, and I appreciate some of our team have some ongoing projects with Warwick. So for example, our intelligent transport team, as well as our access to space team. We also host a researcher in residence together with the Warwick Manufacturing Group based in Warwick University, but also part of the high value manufacturing catapult. And that project is related to autonomous cars using user-centered design and also using space-enabled technology. This is network to do with space sustainability, to do with space debris management, which funded by STFC. Our CTO, Paul, and myself sit on the steering board and help, in particular, academic engagement and how academic can work together with SMEs in this area as well. In terms of working with Oxford University, I just give you some examples here. So they're ranging from collaborative research, training, all the way to commercialization. In terms of collaborative research, we have some interest in AI, machine learning, which is a very important area, and also is a very enabling technology for all different sectors. In terms of skills and training, we have run some successful satellite data 101 workshops for PhD students to give them a hands-on experience of working with data to benefit their PhD projects. Lastly, but not leastly, we're also working with Oxford University to help commercialize their spin-out companies and provide advice on market opportunities, for example, quantum computing. We also have a researcher in residence who is using AI to look at mining dams and also tracking elephants in developing areas for the UN Sustainable Development Goals. The other key area we have been working together with Oxford and also actually the Oxford and the ARC university groups is to develop ambition for the space and for the adjacent sectors based in the ARC region. So I can show you here very quickly about this ambition. And at the moment, we are trying to develop some understanding about the region, the ecosystem, and try to develop a £360 million business case to develop the local ambitions and unlock the untapped potential so that this area become a world-leading ecosystem for space. So this That's everything. I want to give you a quick overview about what we are doing in terms of academic engagement for knowledge exchange and commercialization. Thank you very much for your time and for listening.
Thank you, Ling, and thank you, Emma, and thank you, Mike, as well. Great, thank you for the presentations. It was super. It gave us a very clear overview. We're gonna move on to questions, if that's okay with all of you. I don't know if Mike is still on call. Mike, are you there? Okay, I can start with a question for Emma and Ling, maybe. So I actually just started working for Seraphim Space Camp, so I'm very interested in actually how close your collaboration with them are, and how much you contribute to every space camp, for example. And I was also wondering if you worked with other types of VCs or investment funds to help, the startups that you help tech transfer.
Well, I'll answer your second question first, which is Seraphim is the one that we work so closely with because they've got your space focus. In terms of our contribution to the camp, we're involved in a number of members of staff, but the head of my team, the head of business strategy, goes in right at the beginning, meets the cohorts, and then we do various support sessions. But we tend to have, back in the days when we could meet face to face, we had a 1 or 2 day event. I think it's sort of towards a halfway point, maybe a bit further, where all of the companies coming through the camp would come to Harwell, and they'd meet with various people from across both the technology and the business strategy team. So we do these diagnostic sessions with the companies. We look at where they are in terms of their maturity with the pitch deck and all the rest of it. And then we sort of kick the tires around the technology and the market opportunity where we're that critical friend. And then we use also those touch points to extend their networks. So if they're looking for value chain partners or more information about a particular sector or whatever, we help with that too.
Great, thank you.
Yeah, just quickly adding on that, we also work with Deloitte to support their Gravity Challenge. So Gravity Challenge is just a brand name, so it's not specifically related to anything gravity environment. I can post that challenge program in the chat if you want to find out more about it.
Yeah, sure, we can distribute it. Thank you.
Thank you for that. That's really interesting. The space sector is very dynamic. How do you keep informed about all the innovation at the international level? And do you collaborate with other institutions around the world?
Mike?
Sure. Yes, I mean, some of it's by the ways most of us do it, by information on the internet and wider media, but most of it, the information we have, it comes from basically direct interactions with companies, the things they say about other companies. We use those to form networks and put together larger pictures in terms of what's happening, identifying trends and direction of travel. The split, I guess, is 50-50 between international and otherwise. What was the second question?
I think it was just if you work with other companies internationally.
Yes, we do. I mean, a multitude of them. I'd say probably our split is about 50% in the UK, 25% in the US, and the other 25% split more globally.
Fundamentally, our mission, though, is to grow UK companies. So we do have some flagship programs, innovation support programs, one of which is our in-orbit demonstration program, where we are launching 6 satellites. We're in the process of different launches are at different levels of maturity. But we help both the sort of commercial readiness, but also the technology demonstration piece where companies get the opportunities to demonstrate commercial services in space for the first time, and a lot of the costs associated with launch and the mission are discounted through grant funding. And what that does is it gives us an international presence and actually tends to bring non-UK companies to the UK. So there's a lot of inward investment in space startups because it's such a supportive innovation environment in the UK.
Yeah, also you probably heard about the UK government have this overseas aid program. So this is to help a list of DAC countries to grow economically using innovation. So while that UK government have some funding, some are called Newton Fund, some are called Global Challenge Research Fund. And while those programs, we work closely with our international partners. So for example, we help Brazil to overcome the challenges in relation to tailings dam for the extractive industries, because when those clasp, is really a huge challenge and disaster for both economically and societally. And we also work with other international companies to help build their supply chain, to help to grow their local ecosystem as well.
Great, thank you guys. I have a question for Ling and Mike. You both mentioned space debris in very different forms. So Mike, you mentioned that space debris might not be a viable business model to go for. And Ling, you also mentioned on the other end of the spectrum that there's a whole network called, I forget the name of the network, the GSIOS. Sorry, I didn't have time to write it down. And you say that it supports the UN development goals for sustainability, etc. How do you guys think that these two visions might clash for the catapult, or do you think there's still a consensus that people should try to have startups that deal with space debris, or we should just give it up altogether and fund other startups?
There's no commercial market for removing debris. Basically, once it'll be like saying, show me the commercial model for picking up litter on the streets. No one's going to pay you unless it's coming from a central government fund. But the thing is, debris on the street is one thing. Debris in orbit, unless there's a central pot of funding coming from the UN or a group of cooperating nations, which I can't see being the case, I cannot see the business case being viable for any company to state they're going to basically collect debris. And there's also this bizarre misnomer that you can take debris in orbit and convert it into additional things. Once something's been in the space environment for 5 years, it's pretty much useless. You're not going to, there were concepts about autophaging where you convert the material basically into a propulsion. You use that to move yourself to the next point. But usually the whole of these ideas usually fall down when people fail to understand the enormity of space. So, what are you collecting? Are you collecting something which is the size of your fingernail, or are you collecting something the size of a bus? And these two things might be literally the distance between New York and London. And you've got to get between the two of them. So yes, there's definitely a market for orbit raising satellites, which have run out of fuel or have useful life. Yes, there's a market almost certainly for companies who their spacecraft should have deorbited, but they didn't for one reason or another. So they now have a legal responsibility, or they want to free up that orbital slot. But a market for going around collecting random bits of junk, basically, and there's an awful lot of it in orbit, I think is firstly impossible because there's so much of it. And secondly, I cannot see who would realistically fund that unless you can get the Bill Gates Foundation basically to fund it in some sort of philanthropy-based approach. And then even frankly, what is success? You can say, absolutely, we removed 11 pieces of space junk this year. That only leaves a remaining 97,000 pieces left. Oh, and the engines did an anti-satellite test. We've got another 40,000 pieces of junk now. So the best thing to do is to encourage good practice, good housekeeping, and management of existing assets, and then perhaps look at a more global responsible fund, which might deal with some of the additional parts which are still up there.
Great, thank you. Very, very insightful.
I'm going to temper what Mike said slightly in that our role as a catapult is absolutely to anticipate market demands in markets that are nascent. And space junk is an identification of need or a problem that is going to become bigger over time, the more and more stuff that we put out there. So it's absolutely our role to say, what, we've identified that there is a nascent market that might be addressable. And then what we often find, especially with in-orbit services, is that companies will go with that goal of solving this need, but will find ways to monetize other services that are closer to market and the lower hanging fruit. So in answer to your question, should we just drop the concept entirely? I don't think so, not just yet.
Great, thank you, Emma.
You're a pragmatist, Emma.
Great, thank you, guys.
Thank you. So if we shouldn't, if there is no commercial markets for this kind of space debris solution, Do you think we should focus more on debris avoidance technology in the future?
I don't think it's going to make great as a difference. There's so much debris up there that sooner or later you're going to get hit by something, you know, and you can spend an awful lot of energy and time basically trying to do orbital corrections in terms of moving yourself around to avoid stuff. I think the consequence is that you're going to be able to avoid so much, but sooner or later something's going to hit you. So having some deployable countermeasures which can mitigate some of those impacts is one thing, but you know, if you're a small satellite, say a 6U CubeSat, and you get hit by something the size of a marble, I mean, it's basically game over. You know, all you can hope is that you don't get reduced into a whole series of additional marbles which go off to hit other satellites. Emma might be slightly more pragmatic.
Well, that was a properly technical question, so I don't want to add on that.
Okay, I have a question for Ling. You mentioned the Space Enterprise Lab. I was wondering if Satellite helps in creating other maybe other networks for startups to stay connected after you maybe launch them, or if you have other types of networks that help startups come together basically, instead of just being individually siloed, you know, through accelerators and incubators.
Yeah, so that is a virtual community and a network space for collaboration.
Mm-hmm.
So it's a quite have loads of different function to tailor to different communities. So
okay, it's not just startups.
No, it's not just startups. So for academics, they might have very different demand or needs as opposed to startups or as opposed to multinational large companies. So that network is really trying to meet various stakeholders' needs and have a virtual mutual place for them to collaborate, to find, for example, for PhD students, maybe it's an area for you to find mentors. And for some startup, also an opportunity for them to find mentors as well, because SMEs sometimes struggle during COVID. So it's really a quite large community, but it's based on a virtual platform.
Great, thank you so much.
Thank you. So we've got a question from the audience, from Aistis Krigas. You have talked a lot about interesting projects. Is there any opportunity for students to get involved in those?
Yeah, so for PhD, so I presume this is a PhD student, or so that's a different mechanisms for us to engage students all the way from undergrad, master to PhD. So we have internship. So that's probably aiming for the undergraduate level. For PhD students, we sometimes provide industrial placement for PhD students. As some of your PhD funded by Research Council, you have to take about 3 months away from your PhD project to do an industrial placement. We do host those placements sometimes, and let the PhD work on industrial challenge projects. So at the moment, we are working with PhD student with data intensive background to use their AI and machine learning techniques to apply to satellite images for bridge monitoring. The other area we work with PhD a lot is through, of course, collaborative research and development projects. So that's probably why the PhD supervisor, we work together with them. We do run some training workshops, as I mentioned. The Satellite 101 is one of them. So also, if the PhD is really engaged, want to engage in a more widely sense, you can sign up for the Greenhouse, for example, which is hosted by one of the professor at Warwick University. So you can engage wide that way, because I recall one of the secretariat who take minutes of the committee meetings are actually his PhD students. So give him a way exposed to different ways of working. So really quite flexible, and I probably wouldn't be able to give you a very thorough and a comprehensive list how PhD can get involved, but happy to have a one-to-one chat with you to find out what exactly the needs of this particular question.
Great.
Thank you.
Thank you. I have a question for Emma. You mentioned that potential startups or academics have a current, they have like a IP portfolio. What does that portfolio usually entail? Is it a few patents? Is it just the knowledge that the research that they've come through and published through journals? Could you expand on that, or just give us a broad overview?
Sure. I mean, it's a whole host of things. Sometimes you get somebody who's very far down the road and they've spent a long time in their sort of academic career focusing in a particular area. And then sometimes you get students who are, Mike's working with a bunch of, I think, postgrads who, came out of their engineering degree and then just went straight into a startup and have started developing their IP post leaving university. So you get a whole range in terms of them, where they are, their maturity.
Great. Thank you.
Thank you. I think this might be the last question because of time constraints. So it's another question from the audience. Chris asks, the UK government a few years ago had announced that they aim to capture 10% of the global space market by 2030. Is the UK currently meeting this target? And from Catapult's point of view, what more do you think could be done to achieve that target?
So we are, I think when that original strategy was released, we were about 4%, and we've in recent times moved to about maybe 6%. We're still far away from where we need to be to hit that target at 2030. The things that need to change, I think, are the things, investment is there's just not a patch in terms of the available investment to, in the US, for example, that there is over here. And also one of the things I think that we can fundamentally change in terms of our skills base is an injection of entrepreneurial spirit and skill sets very early into sort of engineering and science-based degrees. Because what I see a lot of times when I'm working with startups is that sometimes you find a UK startup and a US startup who are trying to both go for an emerging market with a similar solution at the same time. And the US startup will have made half as much progress and maybe raised 10 times as much money because that ambition is there, and that risk-taking entrepreneurial spirit that you need to sort of drive forward, and that figurehead that's willing to take those commercial risks tends to be missing quite a bit. So we tend to get groups of people who are very capable from a technical perspective and are working up some really, really smart solutions, but have less engagement on the customer side and less skill set there and less recognition of the need to be able to feed that both financial and commercial element to the startup. So that's my perspective. We need more entrepreneurs at this stage. So that's part of the reason why we're here talking to you guys today.
Yeah, I think space is remaining as the government's priority area. As you may know, the Prime Minister have some interest in this area. And we set up the National Space Council, which reports directly to the Chancellor. And also we are launching the National Space Strategy, co-developed by UK Space Agency together with MOD. So it is a very important area. In addition to what Emma mentioned about skills, about ideas, and also about funding, the other thing we're working together with UK Space Agency is to look at the regional potential. So the Oxford-Cambridge arc area is really a very important area because this is a pan-region, and we're looking at the untapped potential, how to replicate the success of other space ecosystem in the States, for example, and in Singapore, and make it unique, building on the, of course, Oxford and Cambridge, the world-leading universities' capability in innovation, but also looking at the adjacent industrials capabilities to help grow the UK economy.
Great, thank you. I have one quick follow-up on what you just said, Ling. Regarding this arc, do you think, I mean, I'm very biased coming from like Harwell and the Oxford space, but do you think it won't be a bias towards maybe the majority of the activities being centered around the Harwell space clusters, considering there's already one, for me, I don't, obviously there's space activities, in Milton Keynes and between and Cambridge, but I was wondering if obviously there will be a heavy bias when it comes to this arc towards the west then?
Yeah, thanks for highlighting that this is the a risk and also challenge we identified at very early stage, because however it is more advanced, because it's about 10 years ahead of other space clusters or gateway, whatever you call it. But if you look at the whole region, each local area have their own strength. So however, have space cluster already, but they can't do everything all by themselves. And you need the complementary skills. For example, Cranfield have very strong natural environment strength. Cambridge have very good strength in AI, machine learning, and you do need to combine them together. And also, the ARC region can't do everything all by itself either. You need to pull in the adjacent manufacturing skills based in either Midlands or the North Powerhouse. So we really want to use that as a pivot point or an anchor point, but drawing other adjacent or the whole UK skills and capabilities to help the whole UK become a world-leading space country.
Great, thank you. And on that very exciting note, I'm afraid we're run out of time for questions, but I want to thank Emma, Ling, and Mike so much for helping us and answer questions today and giving their presentations. And if you have any more questions for them, we know we'll be free to relay them to Satellite. Yeah, I'd like to close the talk. Thank you so much for attending, and thank you for all the attendees as well.
Pleasure. Thanks, guys.
Thank you very much.